All right, here I am. I've been talking for the past 5 minutes and uh, realized that when I told it to go live, it did not. So, but it looks like we're rocking and rolling now, I guess. Apologize for that. That was so weird. Okay, well, I guess I get to start over. Now I feel like a complete goofball. Anyway, if anybody read the description of tonight's episode, um, I've been doing some research and some of the stuff I found uh, last episode when I was scrolling through was that this design will not work at all. Um, from about the laser aperture back. So I'm gonna have to one fix that, and two, I was talking about the struggles with the MHD and why it isn't a thing. And I was looking for some more information, and I came across this kind of funny uh, deal. This was back in 2013, it looks like, and it's a slideshow, I guess, presentation. And towards the end, because I was looking for information on materials that are generally used due to the heat that's produced when breaking down whatever material is being used uh, for this as a plasma. And in it, it says that it's estimated that by 2020, almost 70% of the total electricity generated in the world will be from MHD generators. As far as I know, that hasn't happened. We still have coal, wind, solar, and nuclear. Uh, oh, also hydro dams. Hydro dams. Yeah, that's the name of them. Anyway, it seems that the material sciences has to come up with something anode and cathode, which is basically um, plates, metal plates, where the electrons that are disassociated from or in the plasma field, uh, they have a place to collect and not collect. I won't go too much into the science of it because I don't want to say something incorrect, but basically that's how it is. When like take for example static electricity, rub a balloon on your hair. So what's happening is the balloon, if I remember right, is pulling the electrons out of your hair, giving it a negative charge. No, that's not right. I'm sorry. Hang on. Let me make sure I do this right. Static electricity. Actually, I had a. Oh, I lost it when my computer went down. Okay, let's try this. Yeah. Phenomenon of static electricity requires separation of positive and negative charges, which I got that right. When two materials are in contact, electrons may move from one material to another, which leaves an excessive positive charge on one and an equally negative charge on the other. So, let's see here. Well, regardless, an anode and cathode, those are what are used to create your a collector and a not collector. You guys can read on that if you care. Anyway, point is what I have to do with the design is basically separate this into three parts. I said four, but one part is two of the same item. I need an anode, cathode, and then a non-conductive insulator. that can withstand high temperatures, which we're talking about some ceramics, I would imagine, so that the magnetic poles can be mounted to them. So, long story short, that's what I need to do is basically tear this apart and come up with something else. The other thing I noticed is that they all have nozzles, um, but I still am not wanting to do that just because I think if I can have the plasma confined for a given amount of length, then I can keep that all compressed and the heat losses will not be as much as if I just let it expand and cool off. Hopefully that makes sense. I could be completely wrong on that. Remember, this is a pretty intense um, field of study, and I know enough of it to make me dangerous. That's about it. So, what I'm going to do is I'm going to go ahead and open this part and grab a few dimensions from it. Got a 6-inch opening there, and this would be more like a test. 36 inches there. Let's go ahead. So I've got a 6-inch ID. I need a piece of paper to write on so I don't forget. An ID is just inside diameter, just in case if I haven't said that and people are wondering, hey, Paladin, welcome back. Hopefully I'm not making a fool of myself. 6-inch ID, and we have a thickness of 1 inch, I believe, for the initial combustion chamber. Yeah, 1 inch. 1-inch thick wall. So the combustion chamber is going to be shortened. And I need it just long enough to cover the holes. So I'm going to move this down. Let's look at 12 and see what that does. That hopefully does not create any issues anywhere else. I don't think it will. Oh, well that's not supposed to happen. What the hell? Why did it do that? That's very interesting. Oh, because of the, okay, because the overall is 48. Oh my goodness. So went from 36 to 12, so this needs to go to 24. There we go. Now we're cooking. And I don't like where that's at. Okay, I think I'm gonna change that dimension because I don't like where that landed. And okay, there we go. That's better. And I believe that means I can go ahead and actually I need that to be halfway between, let me change that. So in case if I shorten this up again, yeah, let me do this here. We're gonna go ahead and do from midpoint here to midpoint there, and then put this on the midpoint. That way, if I can shrink that down more, then this will basically maintain that midway point between here and here. All right. And ignition is there. Let me think about this for a second. I've got to, no. How many of these patterns do I have? I have 5. Okay, that's fine. All right, so from here, I think this is going to have to be a flared end. I think I am going to actually have to do that. And honestly, I don't want it that big either. No, let me do this differently. I want here to here to maintain the same distance. So let's do, it's not, let's go ahead and make it an even 10. And then I want this to be 8. You know what? I'm going to make it 6. That way I can do this. And I'm going to make that 2. Let's bring that out to 8 and see what that looks like. And I want, yeah, let's go ahead and make another. That looks nice. Okay, looks like I need to have this adjusted just slightly because, oh, nope, not that. My apologies. This, because it's going to the bottom, and I want that to stay between the flat. There we go. And I'm a little confused as to why that's doing a beveled edge like that. That is really weird. Why is that doing that again? That's kind of funky. All right, well, we'll go from there then. Maybe that can be a lip or something. So I need an electrically insulated piece of material to go from here until it gets to the next part. Now, what this means is that I'm going to have to put my the focal point somewhere in this area for ignition, which means that the assembly for whatever's going in here with the laser will have to angle, can be done with optics. We'll have to angle after it comes through and focus on an area about right in here, I'm thinking. That way the combustion starts right where magnetic confinement begins. At least that's the goal. All right, so from there, this is what I'm going to do. I'm going to create a new part. Now, for right now, since I'm still doing research to find out what materials need to be used, I think I'll just color code them so that I know that what's going to be the anode, what's going to be the cathode, what's going to be the two parts for the electrical isolation or the insulator. All right, so I'm going to go ahead and go on my top plane here. And what I'm going to do is make a circle. And I want this to be just a quarter of a circle. So, let me see here. That's the top plane. You know what? I don't like that. Let's go. Yeah, we'll do it on the front plane. I think that'll be better. Now the inside idea of the pipe, I changed it to 8 inches on the flare. And then there's going to be a gradual expansion. So I'm actually changing the design a little bit, but I'm going to try and keep it as minimal as I can, I think, because let me see here if I can. Did this have? I don't think this had any drawings here. Well, it did. Well, not a great. This is for a nuclear reactor, uh, but basically that's the concept. As the gas expands, they're allowing that to happen, but they're keeping it confined within the tube, and then it escapes. It goes to a heat exchanger. In the Yeah, this is a busy one. Let me see if I can blow that out. There we go. Um, Not a lot of information. This one they're using an inert gas, argon. That might be an interesting deal. What I plan on using is air, maybe. It has oxygen, hydrogen. Sorry, not hydrogen. Nitrogen and oxygen at about 68% for nitrogen and 20%, probably 18, 19, I don't remember. And then the rest of that makes up like all the other gases that are in the air, CO2, uh, and whatever else. Um, so nitrogen is inert, but oxygen is not. It's very reactive, which I'm hoping um, that'll be a good thing to utilize to increase the amount of plasma flow through the system. We'll see. Again, this is kind of like a fantasy pipe dream type thing for me. Even to do a small scale idea of what I'm wanting to do would require probably a buttload of money. Anyway, whoops, I don't want to do another circle. All right, anyway, so let's go with, I'm We're going to start off with 8 inches in diameter. And then I'm going to go ahead and cut that. Let's do it this way. Nope, 45. Oh, it would have been more efficient to do this and make that symmetric. There we go. Now I can change these to construction geometry and then remove the rest. Let's see. And then I want to do, this will be an interesting deal. I want to do, where'd you go? A little something something here. Let's do an extruded, and I'm gonna look at this dead on here. Yeah. First direction is, that's the thin feature, and I want that 1 inch thick, just like the other ones. And I want that to go, we'll make this 24 inches, but I want it to go the other way. And then what I'm looking to do is taper outward, but that's going to increase, the thickness, and that's not what I want. I wanted it to expand. So, okay, so what I'm going to have to do, I can't do it this way. Because it's extruding like that. Let's do, all right, let's get out of that. And what I think I'm going to do instead, let's get back on, let's close that. And do a right plane. And I'm going to test this out to see if this will actually work. I have not done this before, so bear with me if I fail. All right, so I want, go 24 inches on that. And I don't want much. Let's do 7.5 degrees. That's a half of 15. And I want, those 2 points to meet. All right, let's see if I can do that this way then. If I grab this and this is going to be a profile, this is going to be a path, and I grab the sweep. Path is sketch 3. What's this? What is it asking for? Profile. thin feature. That's what we want. Oh, no, I want that to be selected. Select open. Okay. Profile may have to make a solid scale. Oh, okay. All right, so I actually got to, okay. That's right. It's been a while since I've done this, so bear with me here. We're going to offset this 1 inch. And then go ahead and just close that off. Whoops. What the hell's going on here? There we go. All right, now let's, all right, now, boom, boom. Now that should work. There we go. And that is 1/4. Something ain't right here because I'm going to have to, as it gets bigger, this is going to have to increase. So I'll have to do some funky shit here. Yeah, because if I put 4 of those in a round robin, then they're not going to do what I want them to do. So this needs to, as it extrudes away, it has to fill in more because the radius gets bigger. I mean, I guess I could just do a box. Hello, randomizable. Welcome to the show. How are you doing? All right, so let me see here. This is going to be tricky. I'm just going to call this. I'm just going to call it anode for now. All right, I'm going to do a test to see what's the best way to do this here. The other option is to reconfigure it and do something different. Let's just put that in there. And then let me array this. Circular pattern. Huh? Oh, no, 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 no. Why did it do that? I wanted a circular pattern. There we go. Okay. Grabbing that. Uh, can I grab the origin? No, it won't let me do that. Okay. View, hide, show, temporary axis. There is none. Of course there isn't. Let me grab. Okay, let's that was weird. Let's just I don't know. I never seen that before. Let's create, where's the geometry? There it is. Reference geometry, I want to axis. Not gonna give it to me. Ah, there we go. That's what I want. Cylindrical. It's really not going to give it to me? Really? Why is this? I'm a little confused. Why is it doing that? Not at all what I'm completely baffled here. I don't know why they make this shit so hard. Oh, for Christ's sakes. Really won't let me do that, huh? Point and a face plane, which is going to be... Jesus. Okay, that works. I don't know why it made it so difficult. That's just dumb. There we go. Okay. Yeah, that's what I was thinking. Okay, so I need to modify this. Hide. Yeah, it did exactly what I said it was going to do. So I've got to grow that. Now, how can I do that in here? I think I'm going to actually have to design go about this a little differently. Or I can extrude. What is this diameter? That's 8 inches. Okay. But what does it need to be? That's what I need to figure out. All right, how about I do this? I'll make it easier. All right, let's do it this way. Um, let's see. I can. Yeah, we'll just start from scratch. All right, let's get. Woo, hello, cancel, delete. Yeah, let's start over with this. All right, so we'll cheat it. We'll make it easier. Top plane, front plane. We'll do front plane. And I'm going to do this will be 6 inches. This will be 7. And I should be able to do an extrusion on that. What did I say, 24? And if I do an outward draft, direction 2 will be in, wait, that, oh, no, that's not, okay. What am I, 7.5 degrees? Okay, I'm a little confused why this does this. Okay, I remember now. I remember. It's just one of those things that SolidWorks does. All right. So we're going to have to delete this. Yep, delete that. We'll extrude this as a solid. Hello. Uh, 7.5. Then, good Lord. Okay. Then I do the same thing. Sketch that. I got the wrong numbers here again. Son of a bitch. I'll change them. Through all. Yeah, it's supposed to be 8 inches. 8 inches and then 10 inches because I need an inch all the way around and I only got a ½ inch here. So let me change that real quick. 8 inches, 10. That needs to be 8. Not 80. Oh my Lord, have mercy. My goodness. All right, now front plane. Now I'm gonna basically do. Let's see if I do this. Grab that edge. Center line from here to here. Oh, there you go. Here to there. What? Oh my, oh boy. This thing is confusing me because it's doing. Why? Why is it being so difficult tonight? Oh, this is wrong. That needs to go to the next one. Okay, where did I make my. Where's the edge? Did it not make it? Did I accidentally delete it, I guess? Okay. I don't know why. Symmetric. And what is this doing? Okay, SolidWorks is acting really goofy today. And, what? Oh, that's why. There we go. Holy crapes. All right, get rid of this, get rid of that. Now, hopefully I can do an extruded cut on this. And, son of a bitch, that's not what I want. This is dumb. So stupid. that not connected? Good Lord, it's so difficult. That's the part I don't like about SolidWorks, where it doesn't really try and figure out what you're trying to do. Everything else, it does. Why isn't it doing what I want? All right, let's try something different. I am going to get this, I swear. Yes, it can. Just delete. Christ almighty. Delete, delete, delete. If I do I guess I'm not smart enough for this. What the hell's going on with my brain today? I know what I want. It's just trying to get it to do what I want. Do a semicircle. What plane would it need to be on? Um, let's try this. Infinite length, horizontal. Nope. And vertical infinite length. Boom. Go 12. What is that noise? Is somebody yakking? One of the cats yakking in there? Good times. From here to here. 7.5. And this needs to be an inch. 1 inch. And I want this ID. I want that to be 8. And I want this. Oh, that should keep it. Okay. So that, that there, that there. Actually, let's do this. Let's make that coincident with that. That way it's 12 inches overall. And then what I'm going to do is do revolve. Axis of rotation will be here, and I want 45 degrees one way and 45 degrees the other. Perfect. Told you we'd get there. There we go. No, that's still not going to work. I'm so baffled. That's still going to be. Oh my God, damn it. No, I didn't want to edit a sketch. See, this has to come down to here. So I need to add that material. Wonder. All right, I apologize. I don't know why this is so difficult for me. So stupid. Save that. Just throw it in here just so I can figure out what the hell's going on. It won't. Oh my God, again. Fucking piece of shit. Oh, this is really annoying me. Make a damn axis, would you? I don't understand. I really don't. It should not be this difficult. Why? Oh my goodness gracious. Oh wait, it did work. Oh my God. Okay. Fretting for nothing. Don't say. Go away now. All right. Need to double check something here. I believe graphite. Yeah. Graphite, cathode, lithium. That's lithium ion. Carbon steel or cast iron. Can an anode and cathode? Thank you. That's what I needed to know. Good night. Yeah, we'll do it that way. Did I do that backwards? I think I did. That's too funny. Go through all that trouble, and I labeled them wrong anyway. Oh, I need help. Lots and lots of help. Help. Not just anybody. A little bit of Beatles for ya. A la me. Okay. And then I need insulator. Uh, oh my goodness. What am I trying? Oh my lord. Yeah, fuck it. That's fine. And then that'll just not have any. Hello. That'll just not have any appearance whatsoever. There we go. Good night, Nelly. Oops, nope, I want the, there we go. All right, now there's that, which I don't know why it's, let me fix that real quick. Let's do, we'll do a plane right there. And I'm gonna do sketch on that plane, right? Yep, make it that, and then we're gonna extrude it. Extrude cut so I can get a flat place up to next. No, that's not gonna work. One, too much. Still too much. Why can't I? Can I do up to that? No, of course not. That would be too fucking easy. What is this measurement? Good night. There. So what I'm kind of doing is pulling in air or whatever medium, compressing it slightly, and then allowing it to combust and expand. Which is something I didn't really want to do, but I think I have to. Pretty sure. All right, for now, I'm pretty positive I'm going to need an insulator, or this has to be made out of an insulator, probably some kind of a ceramic. Let me look at my materials list here because I don't want it to show titanium because it needs to be a non-metallic alloy. Let me see what they got in here. Edit material. Do they have any ceramics? Other non-metals? They got ceramic porcelain. I think what I'll do is I'll just use that for now. Because I know it's going to be, I mean, you're talking some, it's not going to be like stuff you make the toilet with or a sink. But for now, I know I want it to be, oh, you know what? No, this doesn't have to be um, a high temperature item because the combustion doesn't happen until after. So actually, this can be pretty cheap material. Let's see what other metals are there. Doesn't need to be. I think I can go with stainless steel. Which is not really cheap in itself, but and it's going to be extremely heavy duty. All right, that's fine. We'll go with that. Oh no, it has to be non-conductive. Oh my Lord, have mercy. I'm so sorry, people. Non-metal. And we'll make it out of corrugated paper. Hmm. I need it to be non-conductive. What material should I use? We'll do graph. I thought graphite was a conductor. It's a very good conductor. Okay, so I don't want that. That's what I thought. That's why I was like, why are they? Oh, uh, whew. I guess a plastic would work. That seems really well. Here's what I can do, I think. All I have to have is a non-conductive seal. No, I don't want to do that though. Let's look for non-conductor, high strength. I know I want non-conductive. Uh, huh? High heat furnace cement. I don't know. What do they call that? They call that, they actually have a name for that for when they use it in, what are those things called? Smelters. It's like a ceramic heat. I, I mean, for all that, I can just put it back as ceramic, which, huh? Oh. I'm just gonna put it back as um, ceramic. Can't believe it took that long for me to do that. All right, Jesus. All right, let's go back to here, and then I think what I'm gonna do. So as long as this is non-conductive, then I'm fine. All right. Holy Moses. All right, let's bring in these parts. Nope. No, 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 no. That's not what I wanted to do. God damn it. Insert components. Thank you. Let's look at that again. So they did left and right instead of top and bottom. So top and bottom are my insulators. They got an applied field, but applied field would go top and bottom. There would be one pole here, north, south, or south, north, whatever. Do they? I don't think they have that. Yeah, all they did is, yeah. But it's a pole, like I was saying last time. Um, all right, so we're gonna go insulator on the top and bottom. And this can actually I can make, I'm not gonna do that. I'm not gonna do that. Okay. I want this to line up with, oh, wait a minute. I gotta make sure I'm on the right plane here. Of course. Okay. So I need, So that's my top. Front plane will be bottom. And back plane, where's my back plane, will be top. Okay, so I want this to go like this. I want that to be concentric with that. And why is that so much bigger than it needs to be? That does not make sense. What is going on here? Oh, I know. I don't have this going out quite the height that I need, so I gotta fix that. Good grief. So weird. Eight inches in diameter. What is that? 8 inches in radius now or something? I don't understand. 8 inches in diameter. What is this? 8 inches radius. Oh my goodness gracious. I gotta fix all those. It should be 4. Lord in heaven. I don't know why I didn't pick up on that earlier. And I open up the anode. I should have known. See, this is why this software is a pretty good one, because you catch your mistakes before you really do something screwed up. All right, that's better. And that should be, yep, just like that. That means I'm gonna have to figure out why this does what it does, but I'm not gonna worry about that right now. All right, now, whoops. Now I want this to be, right? Yes, that to be, all right, now that should not move. Seriously, that's not what I wanted. And then I want this to be a mirror. And we're gonna go, is it this one? Yeah, mirror. Okay. Yep, that's what I want. All right, now I can bring in the other two pieces here. be on that plane there. Perfect. Where is it? Insert. Whoops. Display. Come on. Not sure if I like that. The amount of angle, but I think we can live with it. Why is that going to the inside? That was weird. I must have not have picked the correct thing or something, because that was really odd. Okay. Boop. Let's see, right plane to front plane. Boom. All right. Now, from here, that's fine. Type in ceramic coating. High temp. Yeah, refractory. How do you make a high temp ceramic? That's high temperature ceramics. This is not what I wanted. Ultra high temperature ceramics. Kyocera, really? Silicon nitride. 5. I'm gonna need something a little bit more. 500C ain't nothing. Yeah, we'll have to get into that later. That'll take way too much time to look at. All right. So anyway, we got that. Now, and I'm definitely gonna have to get that fixed. All right, let's look at where are we at on time here? About an hour and a half. That's about. All right, let's do this. I'm gonna keep this one a little bit shorter since it'll just be easier that way. Let's see. I want right plain sketch, and what I'm gonna do. Can I grab that? Yes, I can. And actually, I'm just going to close this off by doing a Revolve feature here. We'll do revolved and the axis of rotation. Can I do that? Nope, cannot. at, what is this? What? Okay. I don't understand what it's doing. Revolve. Thank you. Axis of rotation. Now, can I see? View. Where is it? Hide show, thank you. Temporary. There we go. Ah, lovely. I'm still trying to figure out why it did that. That is so strange. All right, there we go. Let's see if that works. Kinda, sorta. What's the difference here? Oh, I need to, okay. I need to pull those back a little bit. That needs to change. Oh, wait. Oh, wait, what? Oh, okay, which one is this one? So weird. Why is it doing this to me? I should be able to just mate up. Nope. Swear to God. So dumb. So dumb. Come on. Still, there's something going on with it. Whatever. Okay, what's going on here? Why is it still, what the Okay, yeah, this is about it because there's shit going on that just doesn't make any sense at all, and it's frustrating me. This should not be doing this. It's merging inside the damn thing, and that's just dumb. It really shouldn't be doing that. Come on. The only thing I can think of is the concentric mate is all screwed up now since the let's get rid of this. Now, let's get rid of, let's just try this again. Yes. Nope. Okay, let's try something different. Just try that and that. Why is it doing this? Get it. Oh, my Lord, have mercy. See, it's sinking in. Why is it sinking in? That should be a straight piece, and yet it is sinking in. See, that should not happen. That is a flat plane, and this is a flat plane. Oh. Wait, what? What is going on here? It's not a flat. Why is it doing that? This should not be. Oh, that's why. All right. Figured out the problem, and I gotta be. All right, I guess I'll just fix them. Jesus Christ. Yeah, that needs to be vertical. So it can actually be a flat plane. Boom. Oh my goodness, why didn't I think of this before? I keep forgetting about that shit. I apologize, everyone. Like I said, been a while since I've done this kind of stuff. And that's going to be parallel with that. There we go, locked in place. Good Lord. Save that, and then we're going to go to this one and change it as well. What? Something ain't right. Gotta double check this. Yep, that's what I thought. Go away. This needs to be like this. I that should do that automatically. I don't know why it does that. Stuff is acting so weird today. Not my night. Goodness. One. Close that. Close that. Save that and close that. Yep, I know. I know. Calm down. Close. Delete. Thank you very much. I'm gonna get rid of all of this. Where's the third one? This one here. Delete. All right, now. Still a little bit big and I don't understand. I'll have to fix that later because there we go. That's what it's supposed to do. Hallelujah. Centric, boom. Oh, goodness. Oh, come on. Then I'll have to double check and see why those are just slightly larger than the OD there. I don't know why. Oh, come on, move out the way. There we go. Well, there's going to have to be some kind of a fastening to where all those pieces connect to this. So I still got to figure that out. Oh, you know what? I'm gonna have to. I have a better idea, and I'm gonna do that. Whoops. Let's see here. No, I'm not gonna do it that way. Nope, I lied. Not gonna do it. I was gonna do it, but I'm not. All right, so here we go. Goodness. Now I got to figure out how all of these are going to fasten together. Which I think what I'm going to have to do. Oh, I'm going to have to shrink that down to make it fit. And then I believe what I'm going to have to do, I've got to have a clamping mechanism or a mounting bracket for these so that they'll fit together. I could have slots and tabs. That would make it pretty cool. Yeah, maybe I'll do that. I think that'll be for next week because I'm really pushing some good time here. You know what? Let's do it. Let's do it. All right. These are going to be, nope, I don't want that insulator. I want this insulator. All right, so what I'm going to do here, now, can I do, let's see, how can I do that? The slot will have to go on a radius angle. Let's just try something here. I don't know if this will work or not, but I want to try it and see. Let's go here to here, like so. that? Nope, we're good. Okay. And we're going to make these 1/4 inch. That gives me, you know what? No, I don't like that. Come on. There we go. All right, now if I do an extruded cut, a revolved, ooh, can I do that? Yeah, revolve cut. I thought I could. Axis of rotation, we're going to view temporary axis here, and we're going to select that. Oh, whoa, hello. I don't want it all the way around, but what I do want is a slot going in. We need to change the direction. Let's look at 15 degrees and see. Hello? 15 is way too much. Okay, 5? Yeah, that looks good. All right, I'm digging it. Okay, and then I want to mirror that. Can I mirror that? Let's see here. I'm looking at it that way. Yes, I can mirror that. Mirror. Boom. Ta-da. All right, that's good. Now I can turn back off the axes. View, where's my view? Oh, hide show, that's where it is. I always forget that. All right. And I'm going to need one of these. Hello. There we go. And I'm going to do the same thing here. I may have to change the color on this so I can just damn see it. All right, let's do a sketch. Oh, that is definitely not going to work. Well, now that I screwed it up, I got to fix it. Parallel. There we go. Then we have here to here. It's going to be 0.375. Actually, probably needs to be uh 372. Give me a little bit. I really did 372. All right, do this one the same. What? What the fuck is this doing here? What the hell? Okay, all right. I think it was selecting the last thing I did. Oh, okay, that has to be parallel too. God. Lord have mercy. 0.372. All right, now I want to extrude. Nope, 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 nope. I'm going to revolve. And I need to get my no view. Hide show, temporary. Boom. And 5 degrees. And we're going the opposite way because I'm going to extrude that out. Oop. All right. Okay. I hate this. Just, can I, here we go. I'll do the part as. They make this so stupid, so difficult, so tedious, but I understand why. Boom, and boom. Mirror? Yes. Blink, done. And we'll turn that off. And let's go ahead and fix this. Oh my goodness. Oh, that one I didn't. Yeah, I left it as the color of the. Okay, so I'll have to fix that one. And we'll open that. And let's fix that. Oh, come on. Fix the part to be red. Blink. There we go. Now, no matter what features I add or subtract from this, it'll all stay the same color. That's how we're doing it. All right. Sketch. Go here. Really? Oh, wow. Okay, whatever. So dumb. First one I did, it made it parallel automatically. Now I'm trying to do the same thing I did. And yeah, because that makes sense. Why would you do the same thing over and over? 372. Whoops, I think I did 375 on that. Yep. That's not what I meant. I meant 2. Yep, okay, that's good. All right. Oh, axis of revolution. Only 5 degrees, and flip it. There we go. View. Hello. Turn that off, and then we're going to get the right plane and that feature. Mirror. that. There we go. Oh, that's not the part I wanted. There we go. Now the only other thing I got to do is figure out the. Yeah, there should be a little minute gap there, and then I'll figure out how I want to secure that. Because whatever it is, it'll have to be something that allows for the magnetic field to be, well, unhindered, basically. Or the magnet, I'm sorry, the magnet itself. All right. Fixed, fixed, fixed. The only thing I don't have fixed is this. What is going on here? Is this not an inch? Well, that's really helpful. That's supposed to be an inch thick. And it tells me it's 55 9.883. That should be 10. Ah, 9.7. Okay, I gotta fix that. That should be 10 inches. Let's look at this again. This out here should be 10 inches. Why is it not? Is it because I'm not coming out enough? No. It's so weird. You know, I could actually simplify this a little bit. You know what, let's do that. Let's go do an offset of 1. Reverse. That's fine. And then I'll just change the features. Ooh, that's not going to make it hard to figure out, is it? Can't do that? Seriously? Alright, let's try this. Okay, what's going on here? Can I extend that? Alright. No, you can't extend it. Okay, we'll let you extend it. Dumb, dumb, dumb. Now it's going to freak out. Yep, excellent. That's what I want it to do. Now we're going to change this not to revolve then. Hello? Can I get rid of this? Are you telling me I have to redo it? It won't let me. Oh my god, what the fuck? I hate this goddamn thing. I'm just gonna delete that feature. No, I do not want to. This is pissing me off. Hmm? That's not what I want. Why is it giving me that fucking dimension? Christ almighty. What? Oh, I went back too far. Okay, that's fine. That's fine. This I can delete. This I can delete. And Revolve that bad boy. There we go. All right, so we actually get to be fancy schmancy. Yes, nothing's going to because that plate now it's bigger. Oh my God. Oh boy. All right, I'll have to figure that out later because that's just annoying the shit out of me and I can't get it. All right, that will be. I went a little longer than I wanted to, but that'll be it for tonight. I actually almost did my 2 hours that I normally do anyway. All right, yeah, that'll be it tonight. What I'll probably do next week is get the figure out what I'm gonna do. Two pieces mate together, not just all of these. I mean, I got the mating done here, doing a slotted feature. Whether or not that's gonna work from a engineering perspective when it's housing lots and lots of degrees of temperature and the plasma. Anyway, all right. That'll be the things to look forward to next week. And I hope you guys enjoyed my rantings tonight and how much of a fool I made myself look. So anyway, I'll catch everyone next week and hope to see you there. Have a good night, everybody.